Hey there, truth seekers, and welcome to the very first episode of Future Archive, the podcast where we dive deep into the art and science of learning, skill development, and personal growth. I'm your host, Curator, and today we're tackling a question that I think just about everyone wrestles with at some point. What is the best way to learn something quickly and effectively? Whether you're a high school student trying to cram for exams, a college student juggling multiple courses, or a young professional picking up a new skill on the side, we all want to learn things fast and actually remember them. But how do we actually do that? Which strategies really work, and which ones are just myths passed around online? Today, we're going to break down evidence-based learning techniques, draw on insights from renowned educators and cognitive scientists, and talk about some practical methods you can start using right away. We'll touch on methods like spaced repetition, active recall, the Feynman Technique, and even how your mindset influences how quickly and effectively you learn. We'll reference some credible sources like Make It Stick, The Science of Successful Learning by Peter C. Brown, Henry L. Roediger III, and Mark A. McDaniel, as well as A Mind for Numbers by Dr. Barbara Oakley and How We Learn by Benedict Carey. We'll also look at research from cognitive psychologists like John Dunlosky, who have spent their careers studying what makes learning truly efficient. So grab a notebook, settle in, and let's figure out how you can supercharge your learning. Let's start by addressing some common misconceptions. There's this pervasive idea that some people are just born smart, that intelligence is fixed, and that there's a secret hack or shortcut that will let you learn overnight. However, evidence from developmental psychology and education research suggests that intelligence and skill are highly malleable. Carol Dweck, in her well-known book Mindset, The New Psychology of Success, demonstrates that believing you can grow and improve, having what she calls a growth mindset, can actually affect how your brain takes on and retains new information. When you see learning as something flexible and not fixed, you're more open to methods that work in the long term. Another myth is that cramming all night is an effective way to memorize information. Students often do it, I've done it myself in the past, but the truth is, while you might remember a few facts for a short time, cramming generally leads to poor long-term retention. Instead, research shows that spacing out your study sessions, giving your brain time to rest and reconsolidate the information, leads to stronger memory traces. This is known as the spacing effect. In fact, let's talk about spaced repetition more deeply. This technique involves reviewing information at gradually increasing intervals. For example, let's say you're trying to learn vocabulary words in a new language. Instead of drilling the same word 20 times in one day and then never looking at it again, you review it once today, maybe once tomorrow, then a few days later, then a week later, and so on. Each time you revisit that word, your brain strengthens the neural pathway responsible for recalling it. By increasing the intervals between reviews, you teach your brain that this information is worth maintaining. According to cognitive psychologists like John Dunlosky, spaced repetition is one of the most powerful techniques to embed knowledge into long-term memory. If you've ever used apps like Anki or Quizlet, you've already been exposed to the concept of spaced repetition. They're designed to bring back flashcards at the moment you're just about to forget the information, which strengthens recall over time. This approach is well supported by research and highlighted in Make It Stick, The Science of Successful Learning, which emphasizes that cramming may feel good in the moment, feel like you're covering a lot of ground, but it rarely results in durable learning. Beyond spacing, let's consider another crucial technique, active recall. Active recall means making yourself retrieve information from memory without looking at the source. It's the difference between reading the same paragraph over and over and quizzing yourself with a question to see if you can remember the key points. When you engage in active recall, you force your brain to strengthen the pathways needed to access that memory. Studies have shown that students who use practice tests and self-quizzing retain information far better than those who simply reread material. For example, let's say you're studying history. Instead of just rereading a chapter on the Civil War, close the book and try to explain the causes and outcomes of a particular battle to yourself. Or use flashcards to ask, what year did the war start? Why was this battle significant? That's active recall. Research by Roediger and Carey, published in the journal Psychological Science, supports the testing effect, where the act of trying to recall information improves your long-term memory for that information. Now, something that goes hand in hand with active recall is the concept of retrieval practice combined with feedback. This means testing yourself, seeing what you got wrong, and then revisiting that material. By correcting your mistakes and retesting later, you dramatically improve your memory retention. We've talked about spacing and recall. Now let's talk about how you structure the learning in your mind. A key skill you can use to learn faster is known as the Feynman Technique, named after the Nobel Prize-winning physicist Richard Feynman. Feynman was famous for his ability to break down extremely complex ideas into very simple explanations. The Feynman Technique works like this. Choose a concept you want to learn. Explain it in simple terms, as if you're teaching it to someone who has never heard of it before. Maybe imagine explaining it to a 10-year-old. If you get stuck, go back to your materials, review the areas you don't understand, and then refine your explanation. Repeat the process until you have a clear, simple explanation that doesn't rely on jargon or memorized phrases. What this does is force you to identify gaps in your understanding. When you can explain something simply, it means you've internalized it. If you can't, it means you still need to clarify it in your own mind. This technique taps into something researchers often emphasize. True mastery isn't about understanding the underlying structure of a concept. Barbara Oakley, in her book A Mind for Numbers, highlights the importance of chunking, grouping bits of information into meaningful units. When you understand how pieces fit together, you can remember the bigger picture more easily. Think about learning a phone number as 3 chunks of digits, rather than 10 separate numbers. By grouping concepts and seeing patterns, you reduce cognitive load and learn more effectively. Speaking of cognitive load, let's talk environment and attention. Imagine you're trying to learn to play the guitar while also browsing social media and texting your friends. Your attention is divided, and guess what? Research shows that multitasking severely hampers learning efficiency. How We Learn by Benedict Carey also discusses how environment and mindset affect memory. Your brain works best when it's allowed to focus. By eliminating distractions, turning off unnecessary notifications, studying in a quiet or at least consistent environment, you give yourself the mental space to absorb and process new information more effectively. Now, let's consider the role of rest, breaks, and time management. You might have heard of the Pomodoro Technique, a time management method that involves working intensely for a set period, traditionally 25 minutes, followed by a short 5-minute break. After a few cycles, you take a longer break. This method is not specifically about learning content, but it can help maintain a high level of focus and reduce burnout. When you return from a short break, your mind is refreshed and ready to engage again. Research in cognitive science supports the idea that short breaks can help your brain consolidate what you've just learned. Essentially, downtime is not wasted time. Your brain uses it to reorganize and store information. Deliberate practice is another powerful concept. In The Talent Code by Daniel Coyle and in Anders Ericsson's research on expertise, deliberate practice is highlighted as a structured way of practicing that involves setting specific goals, receiving immediate feedback, and continually stepping slightly outside of your comfort zone to improve. When you apply deliberate practice to academics, sports, music, or any skill, you push your brain to adapt and grow. This approach ties nicely into learning efficiently because it's not about mindless repetition, it's about targeted improvement. We should also talk about ultra learning. Scott H. Young's book Ultra Learning explores stories of people who learn extremely hard skills in amazingly short periods. For instance, Young completed MIT's 4-year computer science curriculum in just 1 year through self-study. While you might not want to go to that extreme, the principles he discusses, intense focus, aggressive self-directed learning, and constant feedback loops, can help anyone learn more effectively, even if you're just trying to master a single college course or learn a new programming language. These ultra learners often use strategies like immediate application. As soon as they learn something new, they try to use it. This is powerful because humans learn best by doing. Think about learning a language. If you just read vocabulary lists all day without ever speaking or writing, you'll progress slowly. But if you learn a few words and then jump into a short conversation, your brain actively engages with that material, making it more memorable. Let's review a bit and add some practical steps you can take. Adopt a growth mindset. Acknowledge that your abilities aren't fixed. You can improve with the right strategies and effort. Carol Dweck's research shows this can actually influence how your brain learns. Use spaced repetition. Break up your study sessions over days or weeks. Apps like Anki or paper flashcards scheduled over time help maintain material in your long-term memory. backed by robust research and discussed in Make It Stick. Practice active recall. Test yourself regularly instead of just rereading notes. Retrieval practice is a proven method to deepen memory. Apply the Feynman Technique. Try to teach the concept to someone else or write it down in simple terms. Identify gaps in your understanding and revisit them. Chunk information, group-related pieces of information together into meaningful chunks to reduce cognitive load. Eliminate distractions. Study in a focused environment. Turn off unnecessary notifications and consider whether background music helps or hinders you. Manage time and energy. Use the Pomodoro technique or a similar time management system to maintain focus and prevent burnout. Regular breaks can actually help your memory. Deliberate practice. Set clear goals, seek feedback, and push yourself slightly beyond your comfort zone to continually improve. Immediate application. Whenever possible, apply what you've learned right away. This solidifies your understanding and helps transform abstract concepts into usable skills. Reflect and adjust. Take note of which strategies work best for you. Everyone's brain is unique, and by paying attention to what yields results, you can refine your approach over time. Now, I want to add a little on mindset and emotional factors. Learning doesn't happen in isolation from our emotions. If you're stressed out, anxious, or feeling overwhelmed, your ability to focus and remember details suffers. That's another reason spaced study and adequate rest matter. Good nutrition, regular exercise, and sufficient sleep all play roles in how well your brain can take in new information. Sleep in particular has been found to be crucial for memory consolidation. Pulling all-nighters might help you temporarily hold on to something for a test, but it's not going to create lasting understanding. Another factor, especially for teens and young adults, is motivation. Why are you learning this material? Having a clear purpose can dramatically improve your attention and retention. Maybe you want to learn math so you can build your own app. Maybe you're studying biology because you have a passion for medicine or the environment. Having a strong why makes learning feel more meaningful, and meaningfulness is a powerful aid to memory. Let's talk about an example to make this concrete. Suppose you want to learn how to code in Python. A traditional approach might be to read a textbook cover to cover, but a more efficient way is step 1. Start with a tutorial that gives you basics like how variables, loops, and functions work. Step 2. Use active recall by trying to rewrite the code after looking at it once, or explain what the code does to a friend. Step 3. Space out your practice. Learn one concept today, review it tomorrow, then again a few days later. Step 4. Apply what you've learned by creating a small project, maybe a simple game or a calculator. Step 5. Reflect on what you got stuck on and revisit those areas. Use the Feynman Technique by trying to teach a beginner how to write their first Python program. 6. Add complexity slowly, chunking new topics logically, like first mastering basic syntax, then functions, then classes, and so forth. By following these steps, you not only learn faster, but also retain what you've learned longer. Also, consider that learning styles like visual learner or auditory learner, while popular, aren't strongly supported by scientific evidence. Research suggests that while people may have preferences, tailoring material strictly to a perceived learning style doesn't necessarily improve outcomes. What does matter is using multiple methods of engagement: reading, listening, discussing, practicing, hands-on. Combining modalities can reinforce learning more effectively than pigeonholing yourself into a single style. You can also benefit from collaboration. Teaching friends, discussing ideas in a study group, or joining an online community can give you fresh perspectives. Other learners might explain something in a way that clicks immediately. Social learning, when structured well, can reinforce concepts and keep you motivated. To sum it all up, effective learning is not about inborn talent or last-minute cramming. It's about using evidence-based strategies consistently. Techniques like spaced repetition and active recall are backed by extensive research and can dramatically improve retention. Understanding what you're learning at a deep level, through explaining it simply, applying concepts, and reflecting on feedback, creates durable knowledge. Managing your environment, breaks, motivation, and mindset also significantly influences how quickly and effectively you absorb information. Several acclaimed books and studies, Make It Stick, A Mind for Numbers, How We Learn, research by Dunlosky, Dweck's work on mindset, offer guidance that you can apply immediately. So whether you're studying for a midterm, learning a new instrument, or picking up a professional skill, these methods will help you learn faster, retain more, and enjoy the process. Learning isn't just a chore, it can be a journey of discovery that gets easier and more fun once you know how to do it right. And that's it for today's episode. I hope you picked up some useful tips and insights on how to learn quickly and effectively. If you found this helpful, please share it with a friend who could use a little boost in their study game. Remember, learning is a skill you can improve, just like anything else. Next time, we'll dive into another topic related to personal growth and skill development, so stay tuned. Until then, keep experimenting with these strategies, stay curious, and never stop learning.